Hi there. Today we're going to take a look at electroplating. Here are two old diploma questions related. Well, I guess it's a two-part question related to this electroplating question. So we're using it for the next two questions. We are electroplating a bumper, and with electroplating, we're always plating at the cathode. So we know that the bumper's the cathode, not just from the information, but from the picture, because we're seeing that electrons are coming over to the bumper. So it has to be the cathode because electrons are always gained at the cathode. When we're looking at what's in this mesh bag that's going to be working as our anode, we have nickel and copper. What reacts first just depends on what's the strongest. So when you go into a question and it's asking what reaction happens at your anode, we know that anode is the site of oxidation. So we're looking for a loss of electrons. So you're going to have the metal, and the metal that we had available was either nickel or copper. And we can rule out the other two reactions because this reaction here, this is showing a reduction reaction because we're gaining electrons, and same with this one down here. So even if we were looking at the ions happening in solution, if they're going to react, we can still rule this out because this is also reduction. So not that one, and not the one I had circled. So now when we're looking at the reaction that will occur at the anode, it's going to be your strongest Ra. So if you look at placement, you have nickel solid as an Ra and you have copper solid as an Ra. Since nickel is lower on the right hand side than copper, this one is your strongest reducing agent. So that is what will be oxidized first. So your half reaction would be A regarding nickel. Then the second part of this question brings in cell stoich. In this question, it's still telling us that we're being electroplated. The bumper's transferred to the tank that has chromium ions, and we have our current. We're going to plate chromium, so we need chromium's half reaction. So we know it's positive 2 from this compound. So it's going to gain 2 electrons to make chromium solid. That is what's being plated. In this question, it does tell you how much chromium is being plated, and we want to solve for time. So we're going to be using the formula moles of electrons equal the amps times time divided by Faraday's constant, which you can get from the data booklet. So we are going to solve for time. So the only missing variable from this equation is moles of electrons, but we can find it because we know how much chromium was plated. So we're going to start with finding moles of chromium, then we'll turn it into moles of electrons using the mole ratio. Then we can take that value and put it in for moles, rearrange this formula, solve for T. So let's go ahead and do that. So to do that, you're going to start with the mass of chromium that was plated. We're going to multiply this by the molar mass of chromium, and that is 51.996. And I didn't have my data booklet with me, so I just Googled it and I get a longer value. Then I'm going to multiply this because now this gets grams to cancel. I'm at moles of chromium, so now I can use my mole ratio to get moles of electrons. So 2 moles of electrons for 1 mole of chromium. So moles of chromium cancel. And now when we calculate this part, we will have moles of electrons. So let me put that in my calculator and get a value. And whatever value you get, leave it in your calculator because we don't want to round too early. And I'm just going to write this down. So I'm getting 4.8, sorry, let me just double check that, 4.80806, and this number will keep going, and that's moles of electrons. Now I'm just going to continue with this formula here, and I've plugged in moles of electrons. Now my current is 3,750 amps. We're multiplying this by time, and we're going to divide by Faraday's constant, 9.65 times 10 to the negative 4. I'm now second guessing myself because again, I forgot my data booklet. So Let me just look up that value because I don't want to have that wrong. Days constant. Okay, perfect. So we're good to go. Oh, sorry, it's not to the -4. It looks like coulombs per mole to the +4. Okay, looks like it's to the +4. I think I'm getting it confused. All right, so then we'll take that value and we're now going to isolate T. So if you still have that moles of electrons in your calculator, let's multiply it by Faraday's constant so we can get this value out of the denominator. But what you do to one side, you must do to the other. So at this point, Faraday's constant cancels. Now we can divide by amps. Okay, so let's do that. Put that into your calculator. And then we want to realize that the value we get here is in seconds, because within this formula, time is in seconds. So I'm getting this value 123.7, and this keeps going, but this is in seconds. So if I want to change this into minutes, what the question's asking for, there's 60 seconds in 1 minute. So now seconds can cancel. I can plug that into my calculator, and I'm getting 2.06, which is great because I see that answer. So there's a lot of work into this one, but as long as you remember with plating, you only ever need a half reaction. We don't need all that extra information. We don't need to figure anything out. If it tells you what's being plated, which it does here, we're plating a layer of chromium, then we just need that half reaction of chromium, and then we can go from there. If you found this helpful, please like and subscribe. And if you would like me to do any particular video, just let me know and I would be happy to. Thanks.